A common feature of many modern business intelligence tools, such as Tableau and Microsoft's Power BI, is their ability to connect to relational database management systems and then retrieve data from those systems using standard SQL queries. Ontotext GraphDB is an RDF graph database, not a relational database manager, but it can still use the JDBC protocol to give these business intelligence tools a view of GraphDB repository data that looks like a relational table to these tools. This gives you even more flexibility in how your knowledge graphs can contribute to your enterprise's application. To demonstrate this, I'll use the community edition of the DBeaver tool, which can communicate with a large number of relational database managers. The SQL Access over JDBC GraphDB documentation page lists all the details for how to do this. I have downloaded the sample Netherlands restaurant dataset from this page. I've also followed the link on this page to download the JDBC driver file, because the tool that wants to talk to GraphDB is going to need this driver file. I've already loaded the Netherlands restaurant data into its own repository, so I will make that the currently connected one. To create an SQL view in GraphDB, we'll start by picking JDBC from the Setup menu. On that screen, we'll pick Create New SQL Table Configuration. An SQL view is a table, and a Sparkle Select query retrieves a table of data from the query engine. So we use a Sparkle Select query to define the table that will be available in the view. I'm going to call the SQL table that defines the view restaurant_data. I'm going to replace the default select query with one from the documentation page that we saw earlier, because this one was designed around the restaurant data. The 4 variables in the select part of this query mean that we're defining a table with 4 columns. We still need to provide more details about those on the Column Types tab, but luckily this can be automated with the Suggest button, which retrieves information about the data assigned to the variables used to create the columns, such as their names. We could use this form to fine-tune the treatment of this data in these columns, but I will just go with the defaults for this demo. The Preview button uses the query to retrieve some sample data. If any columns in the preview were blank, or if there were no rows, I would know that I needed to debug the query, but this preview result looks fine, so I'm going to click the Save button at the bottom of the form. Then we see it added to the SQL table configurations list. If we look at the DBeaver tool, you'll see that I've already created a driver for GraphDB. I had picked New and then filled it out with the information that we see on this edit form here. I got the class name and the URL template string from the GraphDB documentation page that we saw earlier. Once I created that driver, I created a new database connection. Picked my new GraphDB driver that I had configured, and eventually created the connection that we see here on the left. NL Restaurants data source, and then of the tables, the restaurant data one that we just created. Once we click the name of that view and pick View Data, it shows the data from the RDF repository as if it was being retrieved from a relational database. I'm not going to go into detail about other DBeaver features because there are many other tools that can use JDBC and SQL to retrieve data from relational databases. The important thing is that GraphDB can communicate with this class of tools using the same protocols as those relational databases. So this restaurant data can be pulled into one of those business intelligence tools the same way that that tool might pull in employee data from Oracle or inventory data from SQL Server. We've seen that the basics of setting up GraphDB to share data as a relational view are pretty simple. The GraphDB documentation page that we saw provides a lot more detail about how you can create and customize these connections. So take a look at that to learn more about what GraphDB can contribute to tools that were designed to work with relational database data.